So we're going to continue with the conceptual model that we built in the last lecture. Now we're going to refine this model to come up with a data model or a data structure for storing our data. This logical model is independent of database technologies. That's why we call it a logical data model. It's just an abstract data model that clearly shows our entities and their relationships, but it's a bit more detailed than this conceptual model. Later, when we pick a database management system like MySQL, we'll refine this logical model to implement it for this particular database management system, okay? So, what are we going to have in this logical model? Well, first we need to specify the type of each attribute, like string, integer, float, date, and so on. For example, the student's name is a string, so here in parentheses, we type string. Note that here we have a string, not varchar, because varchar is an implementation detail. It's a data type in MySQL. But this logical model is independent of database technologies, okay? Now, similarly, email is a string, so let's add that here as well. And date registered is a date time. Now, it's often a good practice to split an attribute like name into multiple attributes like first name and last name. With this, we can easily query or sort students by their first or last name. In contrast, if we have a single attribute to store the full name, then we'll have to deal with extracting the first or last name, and this will make our queries complex and slow. The same is true when you have an address attribute. You should break it into smaller pieces like street, city, zip code, country, and so on. This way you can query on these individual pieces, okay? So let's split the name attribute into first and last names. That is better. Next, we need to specify the type of the relationship between our entities. We have three main types of relationships: one-to-one, one-to-many, and many-to-many. The other types are variations of these three types. In this case, we have a many-to-many relationship between the student and the course, because a student can enroll in multiple courses, and a course can have multiple students. Now, if you want to change the type of this relationship, we can select it. And here on the right side, we have this panel. From these drop-down lists, we can select the type of the relationship. Now, you see a lot of different shapes here because Draw.io supports a lot of different visual languages. Some of these icons are part of UML. So down the bottom, you can see the icons for entity relationship diagrams. If this is confusing for you, you can also hover your mouse over each of these relationships. So this is a one-to-one relationship. Here's a one-to-many relationship, and so on. Okay? So in this logical model, we should clearly specify the type of relationship between our entities. At the conceptual level, this doesn't matter. All we need is a straight line between entities. The type doesn't matter, okay? Now, there is something missing here. What if we need to know the date a student enrolled in a course? Where should we put that data attribute? We can put it here on the student because a student may enroll in several courses. Then we need a separate attribute for each course. And we won't know ahead of time how many courses each student is going to enroll in. That doesn't make sense. What if we put it on the course entity? That doesn't make sense either, because the enrollment date would be different for each student. So the enrollment date is not an attribute of the course. It's an attribute of the enrollment, right? So it's an attribute of the relationship between the student and the course. This is a common scenario in the real world that a lot of data modelers don't get right. So here we need to introduce a new entity that represents the relationship between the student and the course. Let me add that here and rename it to enrollment. Now in this entity, we're going to have an attribute called date. And the type of this attribute is date time. Now we need to delete this relationship between these two entities and recreate it through this new entity. So select this, delete. Now a student can have many enrollments, but each enrollment is for a particular student. So here we have a one-to-many relationship between the student and the enrollment. So I'm going to pick this relationship on the left side, add it here. Now let's drag and drop it on the student and the enrollment. So a student can have multiple enrollments, and that is why we have this fork icon on this side. This represents many, right? Similarly, a course can have multiple enrollments, but each enrollment is for a particular course. So once again, we need to add another one-to-many relationship here. let's move this around. So I'm going to attach this end to the course entity and this other end to the enrollment. So one to many, okay? So previously we had a many-to-many relationship between these two entities. Now we have two one-to-many relationships. You see that a lot in modeling relational databases. All right, so now we have a new entity that clearly represents an enrollment for a student in a particular course. In this entity, currently we only have one attribute, that's the date. But let's say we talk to our domain expert and we realize that courses are priced differently over time. So each student may buy a course at a different price. Where should we put that price? In the enrollment entity. That is the price a student pays at the time of enrolling in a course. So let's add another attribute here, price. And the type of this should be float because we can have digits after decimal point, like $49.50. Once again, at this level, we don't care what is the name of the corresponding data type in MySQL or any other database management systems. That's why we use float. Now in MySQL, we're going to use decimal. In another database management system, we might have a different type. Our logical model doesn't care. This is just an abstract data structure. So compare our conceptual model with our logical model. Our conceptual model doesn't really give us a structure for storing data. It only represents the business entities and their relationship. And we use it to understand the problem domain and communicate with the domain experts. Our logical model adds more details to our conceptual model. So now we almost know what structure or what tables we need to store our data. The entities that we have here eventually end up as tables in our database. All right, now let's add the type for these attributes as well. So title is going to be a string. Price is going to be a float. Instructor is going to be also a string. And tags, we can keep things simple. So we can use a string. And if a course has multiple tags, we can separate them using a comma. Now, you might say, Mosh, this is not a good idea. I know, we're going to talk about it later when we get to normalization. So for now, let's keep things simple. Next, we're going to take this logical model and implement it in MySQL.